Hi, everyone, and welcome to our webinar, MySQL Options on AWS, Self-Managed, Managed, and Serverless. My name is Yoav Elad. I'm a Senior Product Manager at AWS. Today, we're going to focus mostly on our product line called Amazon Relational Database Service, or RDS. For those of you not familiar, it includes 6 database engines that you can choose from, which you see listed here. It's a managed database service, meaning that you don't need to do anything as a user to install or patch or backup or any of these other common administrative tasks. So it's very easy to administer. You can choose the database that you need depending on your application from among these database engines. And it gives you a lot of capabilities around availability and security, which we're going to talk about today. As you can see, some of the databases in this slide, on this slide, are MySQL, or from the MySQL family. So you can see that MySQL and MariaDB are listed here, in addition to Amazon Aurora, which is a MySQL compatible database, which we'll go into in some amount of detail. If you look at these engines, you'll see that some of them are open source and some of them are commercial. So you can choose those two choices, and you can use Aurora, which is a cloud native database. So in this webinar, we're going to focus on the MySQL family, as we said, which is basically the 3 engines which are highlighted here. We'll also compare how that compares to running your own database on your own, which you can also do in the cloud, and doing the administration on your own. So we'll see what the advantages are of running your database as a managed service. So here's what we're going to cover today. We're going to talk about why MySQL in general. Why are so many application developers choosing MySQL as the basis for their software applications? We're going to talk about managed versus unmanaged databases. What are the advantages of having the cloud service provider do the entire management and automate it for you? We're going to compare Amazon RDS, which is the standard MySQL database, with Aurora MySQL, which is the separate MySQL compatible database, which is cloud native. And we'll do a short demo of Aurora Serverless, which is an exciting option that came out in 2018 to do a complete database deployment without having to manage any hardware or choose any hardware configurations, just letting the system scale the database for you. Okay. So let's get started. Why MySQL and why a managed service? So we've been looking at some research that shows the popularity of various database engines, and you might have seen some similar surveys online. MySQL is still the most popular database. This is a survey that was done among Stack Overflow readers. And you'll see that the MySQL family, both MySQL and MariaDB, have received a very high number of responses in terms of usage. The same question was also asked specifically among professional developers, and Stack Overflow got very similar results. Postgres is also becoming very popular, but MySQL is definitely still on top from 2019 surveys. So that is a good reason, at least for many situations and many applications, to choose MySQL as a database. But what does it help you that other people are using the same database as you are? So obviously, it means that the database code has been very widely tested and it's very stable. There's a large ecosystem of tools, of software companies that provide support and develop their applications on the same database and can provide technical support and software and professional services. And there's a large community, multiple websites, and including Amazon's and many others, where people are discussing MySQL databases and can give tips and can help you with your problems. So those are good reasons to choose MySQL, but why run it as a managed service? What's the advantage of having it just be automated and run by a cloud service provider? So from our experience, we see that most of the very common database administration tasks are very low value. We sometimes call it undifferentiated heavy lifting. So doing backup and recovery, setting up very basic security configurations, doing scaling up and down or in and out, patching, monitoring, all of these common administrative tasks are fairly low value. I don't think anyone really makes their career out of these things anymore. And these are things that can simply be automated and run in the cloud, which leaves database administrators and software developers to focus on the more high value software and application development tasks, like designing the database schema, creating and optimizing queries. That's really where there's a difference between how you use the database and anybody else does, and that's really where the value is. So increasingly, we see that people are moving to this managed mode where the service simply takes care of all the activities that you see on the right side. It just frees up time to do the real high value work. So let's talk about how Amazon RDS does some of those tasks for you. So as we said, having using a popular database for your software application is a good idea because you get so much support from others and you get a stable and reliable product. In the case of Amazon RDS, it already has hundreds of thousands of customers. So it's definitely one of the most popular services in AWS, and these are some examples of very well-known companies that are using RDS today. And this shows you RDS customers across multiple engines, so MySQL and others. And as we said, this gives stability to the code, but in the case of a managed service, it also provides the extra benefit of what you could call operational excellence. So since we're running a very large database fleet with hundreds of thousands of customers in it, it gives us a lot of experience in dealing with issues, dealing with hardware failures, dealing with software issues whenever they arise, recovering from any kind of error. A lot of these things are obviously automated when we do it at high scale. And this gives you some comfort that your database is going to be has very high uptime and be managed professionally. So the second thing is the innovations that we added in Amazon RDS. And here we're talking not necessarily about the database itself, but more around how the database is managed, how it's deployed, how it's secured, things like that. So let's focus on a few things that are really show you how running MySQL in Amazon RDS really stands out from just managing it on your own and just having your own deployment. So let's talk first of all about high availability. So a few things around availability. One is how we do failovers and how we ensure that the database will be able to keep running even after hardware or even regional failures. Second thing is disaster recovery. How we replicate the database across regions. We'll talk about backups and snapshots, and we'll talk about point-in-time recovery. So let's start with failover. So for those of you not familiar with the concept of an AZ, that stands for availability zone, and that's basically a set of locations where AWS services are deployed. So availability zones are close to each other so that if we need to copy data from one to the other, we can do it at low latency, but they're far enough so that if a disaster happens, it's likely that even if one of them goes down, the other one will keep running. So in this example, you see a MySQL database running under RDS, and it's running in two availability zones where one of them is primary and one of them is standby. That's a very common mode to run a database in AWS, is to put it in at least two availability zones so that, as we said, one of them will survive even if one of them goes down, in that unlikely scenario that one of them goes down. The application in this example is talking to the primary database. And the storage is using EBS, which is Elastic Block Storage, which is an AWS storage service. And you see that the application has the DNS, or IP address of the primary availability zone, or the primary database. In the case of a failure, if either the automated monitoring system in RDS detects a failure, or if you create a failure, or let's say a failover on your own programmatically through an API, then we can redirect the database via DNS. We can redirect it to go to what used to be the standby database, and now it's becoming the primary database. So this is basically an active-passive configuration, where the passive database in availability zone 2 was continuously syncing with AZ1, and now it's becoming the primary database. And in this case, the original AZ, which used to be the primary, is now becoming the standby. So the application is basically being redirected automatically to talk to availability zone 2, and your application doesn't get interrupted. Now, in the case of adding additional databases for scaling purposes, here we're not doing it for failover purposes. Here we're adding additional database replicas just to increase our read scalability. So you can do that to relieve pressure on your source database by adding read capacity. You can add up to 5 read replicas per database in RDS MySQL, and the replication lag is low, and you can monitor it using our standard monitoring tools. So in this case, you can direct your read workloads to any of these replicas, and it's getting replicated continuously. So this is for scalability purposes. Now, for disaster recovery, what you would probably want to do is replicate your data across regions. So in AWS, you have more than 20 regions which are located around the world. You can use a cross-region replica so that the data gets replicated asynchronously to the other region in the very unlikely situation that a region goes down, or that you lose connectivity to that region. Let's say that I have a database running on the US East Coast, and I lose connectivity. I can set up in advance a read replica in another location, in another city, maybe in Europe or somewhere like that, and then I can recover pretty easily from that disaster, because all of my data has been continuously replicated asynchronously to the other region. So if you're in a multi-AZ configuration, which we're describing here, then you also get the benefits that we talked about earlier. So you can see in this diagram that we're replicating both within an availability zone, which gives us high availability and quick failover, plus we're replicating to the second region, which gives us very easy recovery from a disaster. You can also set delayed replication, which is a feature that came out more recently, if you want to protect yourself from your own mistakes. So you can say that you can intentionally ask to have a replication lag when you're replicating to the other region, so that if you make a mistake, you know that the other region is, let's say, 5 minutes behind, so you get the opportunity to recover from that error. So that's an optional feature in case you want to make it intentionally delayed. Moving on to backups and snapshots. So the backups that are done for your MySQL database under RDS can be either automated or manual. The automated backups happen every day. The entire database gets backed up so that you have a daily copy of your data. You can also take manual snapshots, where you just ask to take a snapshot, and you can then get a snapshot at that moment, which you might need for other reasons. The snapshots are stored in Amazon S3, and they are you can easily restore, or you can take a copy of that snapshot and use it for other purposes, even outside of the RDS service. You can do point-in-time recovery, obviously, from any of those backups that you keep. So what we do is we create checkpoints once every 5 minutes so that you can do point-in-time recovery from any of those recovery points. And then finally, you can share snapshots even across AWS accounts. So if you have multiple accounts, for example, within your own company, and you're setting it up that way in order to increase security and prevent certain parts of the organization, for example, from looking at data belonging to other ones, then you can selectively decide to take a database snapshot and share it across those accounts. Okay, a few words about security and manageability capabilities. There's a long list here. Maybe I'll highlight 2 or 3 things here. One is authentication with AWS IAM, or Identity and Access Management. So that allows you to set up your entire set of user accounts and permissions in a central location, which applies to all AWS services, including RDS. And when you set that up in IAM, it becomes very easy to add or deny access to your databases that way. Second point is around automated updates. On a regular basis, we update or patch both the database binaries and the operating system, or the Linux operating system that they're running on. That is automated, and if you have multiple replicas for your database in a multi-AZ configuration, it becomes a very quick and non-disruptive process to do those updates. And then finally, I want to mention per second billing, which is a fairly new capability in RDS, where instead of charging per hour, we charge per second. So that can reduce your bill in some cases. I'm sure that most people are running their databases for much longer than that. But just as a nice kind of cost-saving measure from our customer's perspective, we bill on a per second basis. Let's talk about a few interesting capabilities in RDS that came out in the last year or so, which I think might be useful for you. One of them is called recommendations. That shows up in the Amazon RDS console as a set of recommendations which basically look at your database configuration and find common errors. A lot of them are around database versions, around security settings, around backups that haven't been done. So these are things that you can control, and if you set these parameters in a way that is not recommended, you open up the security too much. You're using an old database engine version that most people have already moved off of, then you can see a list here. You can either apply a fix or dismiss them, or dismiss these fixes. In the last few months, we also added support for Amazon Aurora, which we'll talk about later. And we've added support for recommendations around parameter groups, which are settings which you can set specifically for each database instance. So it's recommended to try to keep this down to 0, or at least try to at least look at these recommendations and dismiss them if they're not relevant to you. Second interesting and very popular feature is start-stop. So if you go to you select your database in the console, you'll notice that there's an option. You can see it on the right, which is called stop. What that does is it basically stops or pauses your database until you start it again. Most typical usage for that is probably for development and test. So you have a database that you're using for QA purposes. You're done running your test. You can stop it and then start it again fairly quickly when you need to do more testing. While the database is stopped, you don't pay for the instance. Meaning you don't pay for the database which is running. The only thing that you continue to pay for, obviously, is the storage of the database. So if you have your data and you have not deleted it, you continue to pay storage costs, but you don't pay for instance running costs. The databases are always restarted if you don't start them within 7 days. That protects you from just having all these, zombie databases sitting there paused while you continue to pay for storage, and while we have to continue holding them in stopped mode and not being able to use the database. Recent updates to performance. The instance families, which are supported by RDS, and we won't go into all the different details of what each family is best for, but basically they come in the R, M, and T families, which are 3 out of the many instance types which you can find at AWS. So we continue to update to newer versions of these inside of these families as new hardware comes out. So the latest ones are R5, M5, and T3, which are much faster than the one that came the year before, but still at the same price. We increase the storage size to 64 terabytes. So that's, I would say, enough for the vast majority of databases that we've seen. Most of them are much, much smaller than that. And the amount of IOPS that you can do from a single database is up to 80,000. Okay, a little bit about how you monitor your database and test it and test your query performance. So Performance Insights is a feature which comes with the Amazon RDS service. It works for every one of the database engines, including MySQL, MariaDB. And basically, it's a very simple dashboard that shows you a set of performance metrics across time. So you can see that at the top where we're looking at our database performance and where the bottlenecks are, plus a list of the SQL queries which are using the most CPU. So this is basically something that you can use both to monitor performance, and even during the development and test phase, you can look at the SQL queries that you're writing and analyze them and improve performance. You can adjust the time frame, like in many dashboards of this type that you might know. It's a very familiar type of UI where you can stretch the time. You can look at it hourly, daily, monthly, and all of that. In Performance Insights, you can look at data from the last 7 days for free. So it just comes with the service. And there's also a paid option if you want to keep data for longer than that, up to 2 years. In addition to Performance Insight, there's other ways to monitor performance of RDS databases. One of them is CloudWatch, which is a more common, or I would say a more generally applicable way to monitor AWS services. So in Amazon RDS, you can look at you can look at metrics in CloudWatch, which are basically operating system level or virtual machine level metrics, which are mostly hardware related. So you can look at CPU, you can look at memory, read, write latency, things like that. So that applies not just to your database, but also to any other AWS service. And if you have any monitoring tools that work off of that, then you can look at Amazon RDS together with the other services that you're running. And you can set alarms and anything else that you can do in CloudWatch. In addition to that, enhanced monitoring looks more specifically at operating system level metrics. So that's in addition to the standard hardware details that you see in CloudWatch. You can look at additional metrics which are more specifically related to the fact that we're running a database on this operating system. There are multiple third-party tools that work off of the data here and allow you to monitor your database through those tools. Other ways to monitor database activity would be to export all of this CloudWatch data as an object, for example, here in Amazon S3, and then query all of that data using query tools. So Amazon Athena and QuickSight are two examples of AWS services that allow you to query data in S3, but you could basically use any tool of your choice and you can use that to look at all the events that happen in your database, to search for them, to set alarms, to visualize them. Basically, any tool that can work off of the Amazon S3 service would be a good would be a way that you can analyze your database metrics and events. Okay, the last thing I want to say about Amazon RDS before we move on to Aurora is just to point out the openness of this platform. So basically, you're running your database on AWS, but it doesn't mean that the data is always will have to remain in AWS. So you have the full ability to migrate the data in and out of the service. So using our own AWS database migration service, which is a very low cost database migration tool, or any other tool that you choose, you can take data and you can migrate or replicate it into Amazon RDS, but you can also replicate it out. So in the example of AWS Database Migration Service, you can migrate data from multiple other database locations, such as databases running on Amazon EC2, databases running on premises, data warehouses like Redshift and several others. You can just you can migrate and extract the data and move it into Amazon RDS. But in the same way, you can also do the opposite. So you can also migrate the data out. I would say that this is more common in the case of replication, where you have an Amazon RDS database, but you also need to replicate the data to a different location, which could be on AWS or even on premises or another cloud or wherever you need to replicate the data or migrate it. You can do that as well. So we really believe that you should have complete freedom to move the data in and out at any time, and you should be able to do that at a low cost. Okay, so everything we've talked about until now was basically a MySQL database, a very standard, familiar MySQL database, simply running on RDS in the cloud with some additional management and monitoring capabilities. And what we're going to talk about now is Amazon Aurora, which is a separate database engine, which is compatible with MySQL, but with additional capabilities beyond what you have in a standard MySQL database. So Aurora is essentially a database with enterprise capabilities, which is still compatible with MySQL and comes at a very low cost. So the goals for Aurora when we created it a few years ago, and it came out in 2015, were to provide the same speed and the same availability that people are used to from high-end commercial databases that usually cost a lot of money, but also with the simplicity and familiarity of MySQL and also Postgres open source databases. So it's completely compatible, but it's also faster and gives you more enterprise capabilities. So let's talk a little bit about what makes it different and what makes it faster. So first of all, in terms of the architecture of the Aurora database. So Aurora is based on a separate storage system, which you can see in this diagram, where the database basically writes to storage in 6 copies for every time you write data. So the little colorful squares that you see here are basically, you see that the red one is stored 6 times and the purple one and the orange one. Basically every piece of data, every block that the database writes will be stored 6 times across these 3 availability zones. So in AWS regions, we generally have 3 availability zones per region, and the data automatically gets stored in all 3 of them with 2 copies per availability zone. So that's basically a very durable way of storing the data. It's very, very unlikely that 6 separate copies of your data will all get destroyed. So at the basic level, at a minimum, you know that your data is very durable. Now it's your choice how many instances of the database itself you want to run. So you can run a database and create a read replica and put that in a different availability zone or in all 3 availability zones. So how you run the database is your choice, but how it gets stored, it always gets stored in 6 copies. So you know that it's very safe. And there's an entire essentially fleet of storage nodes that are taking the data that are basically receiving the data that's being written by the database and then storing it across these 6 copies. A second advantage of Aurora is that it's very well integrated with the bigger family of AWS services. So with AWS Lambda, if you're familiar, you can write Lambda functions and you can get them triggered when something gets written essentially when something gets written in your Aurora database. You can also create a Lambda function running somewhere else that will read and write data to Aurora, and we'll talk about that a little bit later. You can integrate with IAM, which is the same thing as what we said for RDS MySQL. So you can manage your user roles and accounts that way in a central location. You can load data from Amazon S3, which is generally useful for bulk uploads of lots of data into your database. And you can monitor using CloudWatch, like we talked about for MySQL. So Aurora gives you all of these integrations, but with lots of additional features, which we'll see in a moment. Aurora has also been very widely adopted, and we've been saying publicly that there's tens of thousands of customers that are using Aurora across all industries. It's been a very, very fast-growing service. Now, how fast is it? So because of the changes we've made to the storage layer and other optimizations in Aurora, we've measured using Sysbench benchmarks performance of up to 5 times faster than a standard MySQL database. Obviously, you need to test it with your own workloads. This can vary. It's not always exactly 5 times faster, but I would say the majority of cases we've seen that it's much faster than a standard MySQL database. And these are some comparisons of different versions of MySQL and Aurora, and you'll see that the Aurora benchmarks have come out generally much faster than standard MySQL databases, but it's something that you would want to test on your own. The scalability and high availability capabilities of Aurora are somewhat similar to what we've talked about for MySQL, but with additional capabilities. So first of all, you can create 15 read replicas for every database cluster. This gives you read scalability, obviously, and it gives a good way to also recover from any kind of failure, because a read replica can take over from the writer if there's any type of problem with the writer. So in this example, you see that we have a primary database instance. We're replicating it to our read replica. We're running some other workload. In this example, a BI server is running off of that read replica, and that way we can scale reads. The BI server is running off of the replica, the application is running off of the primary, or multiple instances of the application running off of the primary, and I can add additional read replicas up to 15. So that gives me a total of 1 primary or writer plus up to 15 read replicas. You can have the system automatically scale these read replicas for you. So you can just set it so that if you have a lot of read transactions coming in, Aurora will automatically add read replicas and then remove them as read activity goes down. You can do this replication across regions, and you can do standard bin log replication from Aurora to any MySQL database, whether it's Aurora or not. So a little bit more about read replicas. As we've said, you can have up to 15 per database cluster. One of the advantages of read replicas in the Aurora world is that they're all sharing the storage. So those storage nodes that we were talking about earlier, they're all shared by the master plus all the read replicas in the cluster. So that means that a read replica is literally just reading. It doesn't need to write anything to any separate storage because it's sharing the storage with the writer. So you can set your application to talk to these read replicas directly, or you can set up endpoints and you can configure the order in which it'll access those replicas under your database endpoint. So this way you can scale reads and you still get the advantage of high performance and low lag replication. One of the actual biggest advantages that customers have been reporting for Aurora compared to a regular MySQL database is actually the replication lag. So because the storage is shared, because it's located at the same location and replicating very quickly, the typical replication lag is less than 10 milliseconds, which is much faster than what most people are able to get with a standard MySQL database. Now, I mentioned that you can also replicate your data across regions. So when you do that in Aurora, it's called Aurora Global Database, which is basically a mode where the master region, in this case, in this example, you can see that in Columbus, Ohio, we have an Aurora cluster which has a master in it and 2 writers, and you can set it up so that it replicates to additional regions, in this example, to a few other cities. And those cities basically get very quick asynchronous replication so that you can read the data locally in those cities. So the reason to create a global database is usually one of 2 things. It's either for to be able to do low latency reads in the other region. So I might have a copy of my application or any application that needs this data running in Washington, D.C., for example, and it would be reading the data from those local read replicas. And that way it can read data without having to go to Columbus and read it from there. So the reads are very quick and they're using a local copy of the data. And the second reason is obviously for disaster recovery. So if I lose connectivity to the region where I have my master, any one of these other regions can take over and become the new master. So that's an action which you can trigger whenever you decide that, or you think that there's been a disaster. And within less than a minute, the other region will become the master region. And now you can point your application to that region. So the amount of data that you lose or the RPO is very low. It's because the replication is very quick, and you can recover within less than a minute. Now, recovery in general in Aurora, even when you don't use other regions, if you're just looking at a single region and you look at how we do recovery in Aurora, it's very quick because of the way that the storage system works. So if you contrast that with a traditional MySQL database, in traditional MySQL, usually crash recovery works with the concept of checkpoints. So every few minutes, usually something like every 5 minutes, a MySQL database will create a checkpoint. And then in the case of a crash, all the logs that were created since that checkpoint will be applied. And then we bring the database back to the state that it was. So that's how it works in any MySQL database, essentially, including ours. The problem with that is that you have to wait for those logs to be reapplied, and that can take time. There's no real specific time frame when you know that that'll finish. So it can take a minute, it can take an hour. It's a pretty long single-threaded process happening in MySQL. In Aurora, which is what you see on the right side, it's actually much quicker because we don't even have any checkpoints. So the entire storage system is continuously applying these records as part of both the write process and on demand when you read from the database. So this happens in parallel across all of those nodes in the storage fleet. So when a crash happens, there's really nothing to replay. We just need to, or there's almost nothing to replay. We just need to, as part of reading the data, we just need to apply any remaining logs that haven't been written yet. And that's just a normal part of the read process. So it happens just pretty much as fast as any other read in an Aurora database. So there's no need to go back to a checkpoint and then apply the logs and wait for an hour until they get applied. So customers have been very, very excited overall by how much, how quickly an Aurora database can recover in the case of a crash. That's one of the major benefits that people have seen. And if you look at the typical recovery, these are just some examples of how long it took to do a recovery. These were of course some that we triggered as a failover to see how long the recovery would take. And in the majority of cases, it took less than 30 seconds. So a major advantage. Additional Aura capabilities that might help you, especially if you're when you're using Aura during your development and test phase. So one of them is called fast database cloning, which is basically a way of very quickly creating a copy or a clone of your database. So this is a capability that you might be familiar with from other tools that are on the market, where basically a clone of a database is created very, very quickly. It's not actually a full copy, which could take a very long time for a large database. It's actually just a set of pointers that don't actually copy the data, but just gives you, but it gives you another copy which you can start reading and writing to, which is pointing back to the original database. The only time when new data will actually get created is when you actually write to the new copy of the database. So these two clones are basically sharing the storage, but if they become different, if your application writes something to the clone which is different, that's when it takes more storage. But otherwise, they're basically sharing the same data. So the copy can be very quick. The cloning takes less than a minute because we don't actually need to copy your entire database. So no matter if your database is big or small, the clone is very quick, and you're immediately able to start working with that clone. The main things that people do with clones are, I would say, typically in the development and test process, where you want to test your application or a new version of your application with a copy of the data from production, which would be the most representative data for your testing. So you can just create a clone very quickly, give clones to everyone in the development team, and then you can run tests on that data. Second useful feature is called Backtrack. What Backtrack does is it restores, as the name implies, restores your database or rewinds it to a previous point in time. I would say that that's useful for, let's say, separating it into the production case and the development and test case. In the production case, I think it's pretty obvious. If you make a mistake, you drop a table, you do anything that's destructive to your data, all you need to do is go to the console, rewind it to a previous point in time before that mistake happened, and now you have a copy of the database as it was before. It's also probably recommended to shut down your application while you're doing that, so that you don't write additional data which you might lose. Second case would be in a development and test scenario where you want to rewind your database to a previous state between test runs. So if I have a test that I'm running, it's using my database. Maybe it's deleting data from the database, and now if I want to run my test again, I need to rewind it back so that the data becomes undeleted, and then I can run the test again. So this is something that you might want to put as part of your test framework, so that every time you run a test, you position the database the way it should be before the test runs, and then you can do your database actions, including deleting data from the database. This is also very quick. For us, it's just a storage operation. It doesn't need to do a recovery. It doesn't need to go to a backup or anything like that. It's just a storage operation in our database. Okay, with that, I'll move on to the last MySQL option that we want to cover today, which is called serverless. So serverless has been a very popular concept, not just, I would say, not specifically for databases, but just in general in the industry. The idea that you don't need to do anything to configure a server for software that you're running. So you can write an application. It's become popular, I would say, in large part to AWS Lambda, which is a very, very popular AWS service, where you just write your code. You don't need to worry about what hardware it'll run on. You don't need to worry about scaling. It'll scale up and down depending on the load that you're putting on the hardware. But you don't need to choose any instance types, memory, CPUs, anything like that. So we wanted to bring the same type of thinking to databases as well. Aurora Serverless came out in 2018. It's become a very, very popular way of running an Aurora database. Originally available for MySQL databases, now it's also available for Postgres for those of you who are interested. So the way serverless works is, first of all, at the basic level, since it's serverless, you never have to configure the hardware or to choose what size of hardware you want your database to run on. So typically you would start small and you will just let the system scale your database up and down depending on demand. So the way it works, as you see in this diagram, is that there's a layer between the application and the actual database, which we call request routers. They basically receive incoming read and write requests, and they're a proxy to the actual database which sits behind them. The databases are available in different sizes, and we will automatically scale them up and down, meaning give you a bigger instance or a smaller instance depending on the load on your database. In order to do that very quickly, we're constantly maintaining a warm pool of instances of different sizes, from very small to very large, which are shared across multiple customers. So all of these instances are sitting there. They're basically idle. They're waiting for some database of some customer to need an instance of that size, and then that instance gets allocated to that customer, to that database, and that replaces the previous instance that you were running. So it'll automatically scale up and down depending on the demand that your application puts on the database. And of course, the database writes the storage just like any other database. So the scaling can go all the way up to pretty big instance sizes, and it can go all the way down even to 0. So if there's no activity in your database at all, and if you're interested in setting it up that way, you can decide that the database will completely shut down. And at that point, it's not running at all. You're not paying anything. It's completely shut down. You're just paying for storage, obviously, just like any other database in AWS. But for the instance itself, you're no longer paying anything until it starts up. So the next time that somebody tries to read or write from that database, will immediately allocate a small instance, and now your database is running again. So that's not necessarily the right way to do it for every scenario. I mean, the idea of shutting it down completely, you can configure it whether you want it to shut down or not. So if you're in a production system, maybe you don't want it to ever shut down all the way. You want to just keep the smallest instance size, even if there's no activity at all. If it's a development and test system, I think it's more likely that you might say, okay, yeah, I want it to be shut down completely when I'm not using it, and then it'll just start up when I need it again. The startup after the break is fairly quick, but it's not, it still takes a few seconds to start back up again. So if it's a production system, you might not want users to wait that long. So you might you might prefer to configure it to keep the smallest instance size running instead of shutting it down completely. Now, the types of applications that can benefit from serverless, beyond just any application where you don't want to mess with the hardware at all, is applications where you don't exactly know the demand. So if your application has unpredictable demand, or if it's spiky, if it's cyclical, if you only use your database at certain times of the day or times of the week, and the usage is not smooth, then serverless might be a great solution for you. Now, in order to access data in a serverless database, we added a feature called the RDS Data API. That's basically an HTTP interface to access your database. So what it does, it basically allows you to call, basically to read and write data from your database using an HTTP connection rather than standard SQL access. It's very helpful for Lambda customers. So if you have a Lambda function that gets triggered by an IoT device, such as in this example, then it's very easy to just go open a connection using this API, read and write something from the database, and then the Lambda function can exit. In a serverless database, you would usually use this API either because you have that kind of Lambda situation, or because your application is located in a different location then your database, let's say that your application is running on premises, which in some cases people do that. You want to access your serverless database in the cloud, then HTTP access would be a very easy way to do that. And you don't need to manage these connections. You don't need to keep them open. It's a simple API that you call. So in this way, you can basically match a serverless database with a serverless application. So imagine that your application is serverless. You're using Lambda or something similar to that. It's completely serverless. Now you can match it with a serverless database, and you're not managing any hardware at all. So I'd like to end the webinar with a quick demo just to show you what Aurora Serverless looks like. So let me quickly go to my browser. What we're seeing here is the Amazon RDS console. And let me create an Aurora database and show you how serverless is different from a regular database that you create. So here I'm in the Amazon RDS console specifically, and I am choosing to create an Aurora database. As we said earlier, in RDS you can choose from 6 database engines. In this case, I'm going to choose Aurora. I could have also chosen MySQL or MariaDB if I wanted other MySQL compatible or other MySQL databases. And you'll notice that I can choose either a regular database, so in this example, a database with a writer and readers, or I can choose serverless. Now, the difference that we see here, if I choose standard Aurora database, which is not serverless, which is the item that is selected now, then I will need to go down later and choose an instance size. So here, since I've selected, at least until this point, a non-serverless database, I will have to go here and choose from among all the instance types. And each of them will have a certain number of vCPUs and memory and storage bandwidth and networking and all of that. So a non-serverless database, I need to choose the hardware size. On the other hand, if I choose serverless, and let's go back up and do that, then from this point, the option to choose the hardware is gone. I don't need to worry about that anymore. And I just pay for the capacity that I use under the serverless database. So just a few words about that. What it's telling you here is to choose how much or how many Aurora capacity units you would want to use. So Aurora Serverless, the billing is basically based on this concept of ACUs or Aurora capacity units, which are a certain number. It's a certain combination of CPU and memory usage. And as you're accessing your Aurora Serverless database, as you're reading and writing, you're using database resources in ACU units. So since it's unpredictable, then you just pay for what you use. It's not a consistent hardware size. It can go up and it can scale up and down, obviously. And we're counting these Aurora capacity units. And you can find the price for an Aurora capacity unit on our pricing page. So here you're just setting some limits. If you have an application that you're afraid could use too much capacity, then you can set a limit on how much how many resources you would want it to use. So you can set a minimum and a maximum. One of the options that you can also choose here, which we mentioned earlier, is whether you want it to pause compute capacity completely after there's inactivity. So do you want your database to shut down completely when nobody's using it, and then you have to wait a few seconds until it goes back up when there's new activity, or do you want it just to go down not to 0, but just to a small instance size? Okay, so that basically shows you how you set it up, and from this point, it's just a MySQL compatible database, just like any other. All right, so that concludes our webinar. Thanks everyone for listening. You can contact me. And we'll continue to answer questions via text chat until the hour is over. Thanks everyone, and have a great day.